Sometimes the simplest question has a profound implication and a difficult or complex answer. A simple question that was asked centuries ago is, why is the night sky dark? It doesn't seem obvious that this is a good question, except that in Newton's theory of gravity, the universe was infinite, and an infinite universe filled with objects emitting light and having gravity would have infinite light and infinite gravity. Newton realized the problem of his cosmology, and he had no answer to this puzzle. 150 years after Newton's death, Olbers formulated a paradox of the night sky being dark. Olbers considered an infinite universe and realized that in an infinite universe filled with stars, galaxies were not known at that time, eventually every direction would intersect a source of light. And even though the source of that light was fainter as it was further away, this is true of any direction you go. Why is the sky not bright from all those sources of light, however far? So the paradox results from an infinite universe infinitely filled with gravity and light. By analogy, imagine a large forest. If it was large enough, in every sight line that you look, eventually you would see a tree, however far away. And so your entire horizon would be filled with the images of near and far trees. A simple calculation shows the nature of Olbers' paradox. Imagine the universe moving outward in shells from the Milky Way. In any particular shell, the number of galaxies goes up as the surface area of a sphere, proportional to the distance squared. But the light from any one galaxy goes down by the inverse square law. So the net contribution of successive shells is equal, and an infinite number of those shells moving outward must give an infinite amount of light, or of gravity. That, in essence, is Olbers' paradox. The modern explanation of Olbers' paradox relies on the fact that we live in an expanding ancient universe, and there are two components to the explanation. One is caused by the redshift or the recession velocity of galaxies, which means distant objects have their energy reduced compared to nearby objects, and so as you move outward, the amount of energy or radiation is not the same as for nearby objects. The second is due to the vastness of space and the finite age of the universe. It turns out there's not been time in the age of the universe for galaxies' radiation to fill the voids of intergalactic space completely. By the combination of these two reasons, the sky is indeed dark at night, as we observe. Simple questions can have profound answers. Why is the sky dark at night? Asked Olbers 150 years ago. It turns out that in an infinite universe, the light and gravity should be infinite, yet we do not observe the night sky to be bright from the light of distant stars or galaxies. The answer to Olbers' paradox lies in the expanding and ancient universe, where the light or radiation from distant objects is redshifted or reduced in energy, and so in the aggregate contributes less than the nearby objects, and where the space between galaxies is so large that radiation has not filled the voids between them. Thus, because of the expanding universe, the night sky is indeed dark.